I think it's good morning, still morning, I guess. Uh, and first of all, I would like to thank you to choose to attend this section while the other section are parallelly held. And my name is Sanchuila. I'm the senior research scientist from the CSIRO. And as you can see, my today presentation is about the R&D to address the feedstock characterization and risk associated with the waste to energy projects. Maybe you might see that this slide seems very busy and messy, but it's summarized well about the photo documentation of what I'm going to present. So this present everything. That's the photo documentation of how manually handle and sample the different kind of waste, characterize them, separate them, and then the size them, how they process, and then these are sizes ready for the lab analysis, and then finally we can use those analysis in the waste to energy plant. So that's the whole story of my topic. So the topic is how important the waste characterization and when we get the data, how we can apply it. So bear in mind that I'm not going to only talk about this particular project, but I'm going to share all our involvement as a CSIRO energy division in the waste to energy area, and what we have already done, what we are doing, and then what is our plan regarding with the waste to energy area. So let me start my presentation with a statement. That's a statement from the 2017 from the World Energy Council. The message is giving here is waste to energy is remain costly option, but it's no longer threats to the environment. So what I try to emphasize here is if we follow the certain protocol and standard from the local or the federal or the country environmental authority, you follow the standard, you follow everything, and waste to energy is no longer issues for the environmental problem. So bear in mind that there's one thing that people always tend to overlook. That's the importance of the understanding of the feedstock characterization. So historically, our CSIRO energy has a very strong research area in the coal utilization, especially in the coal gasification. We try to understand the different type of the coal, how they can affect in the real gasification condition. But when we extend this research area into the waste and biomass, so the first thing we do is we try to understand in the world, because we have no waste to energy plant and in Australia, so we have to understand what is the current state. And so the first thing we do is we review, try to understand all the waste to energy technology, including combustion, gasification, try to list the state of art of what is the developments and what is the real practical application in the combustion-based waste to energy, as well as the R&D status of the gasification waste to energy. And from there, we make the list, and also we include in this 60 pages report, we also include one of the case study from the USA, from the Los Angeles County, one of the case study of waste to energy plants, how they handle there, and where one of our team member visited. And in this report, we also include the last project, waste to energy project, tried to establish in Australia, maybe about 2 decades ago, and how and why this project has failed. And so those are all the technical review in here. And from after that, we learned that there is one important thing is very, very critical. That's the understanding of the feedstock and what is their chemical properties and how they change in the seasonal and regional. So without knowing this will be a lot of risks involved in the practice in the real waste to energy plant. So when we understand about that, I tried to find the data at that time, around 2012, 13, and I can't find anything. Maybe there's a data hitting in somewhere, but in public domain, we can't see any characterization and chemical properties of the waste. So we approach but it's reasonable at that time because all the wastes are recycled and landfill. So what we need to know is what type of waste going there, how much plastic, how much food waste, but we don't know what is their chemical properties. We have a lot of data in Brisbane and other major city. They have their yearly or every 2 years survey on about the waste physical properties, not the chemical properties. So we approached the Brisbane City Council, and then after that they funded a small project to do this with the help of the Embrun Kuhn, who normally do the physical characterization of the waste from the Brisbane transfer station. So in this project, we categorized into 9 wastes, as you can see in the top, and the sampling of the waste involved the 6 batch of the waste. 1 batch include the 150 kilogram. After that, we ended with 9 category of the combustible waste, and then after that, what we do is we try to follow the protocol, and also we try to do the protocol that can be sustained, and we can do it in future. We do the air drying, sizing, and also after that, we do the chemical analysis of each component. After that, we mix again with the original, their mixture, and then we measure. So, and then after that, we have the individual one and mixture one. We compare, they are quite well aligned. So this is this is a table, a lot of data including. That's that. I can say that in the public domain, this is the very first waste properties data for the for the Australian waste. And this is quite busy, so I can. Some of them are quite highlighted in there. What try to highlight is the food waste, garden waste. They had a very high moisture content. Because of that, food waste is 20.3, let's say 20 megajoule per kilogram in dry basis, but it moved to the 3.8. It's because of the moisture content. So this highlights how important the moisture content is and how important you need to know about those details. So, but opposite to the food waste and garden waste, and plastic has a very low moisture content, and then they have a very high carbon and hydrogen because they are the petroleum-based waste, and they have a very high chlorophyll value. So from there, this project is represent the Brisbane City Council, one of the transfer station. But using these data, we have the confidence to the certain level. We can also try to find the chlorophyll value of the other place, other city, state council ways to apply this method, and then we can get the chlorophyll value if we knew the physical composition of the waste. So that's what we do in the next step. This is the comparison between the Brisbane and the Sydney, Southern Sydney Regional Council. There's a 15 council involved. This study is done by the APC Waste Management Company, and they spent about 4,000 hours with the 34 tons of the waste, and then finally they got the data. So from data, we try to align with our category, and then why compare it here. So if you look at the very beginning, it looked like they're not similar. But the main thing is different is the garden waste. Because the garden waste from the Brisbane City Council is much higher than the Sydney local region. If I normalize without garden waste, they are aligned quite well, but it's not that this graph is not here. So it can be the two reasons, because of in that Sydney City Council, the land is limited, people live mostly unit and the apartments, so that maybe the waste, green waste, garden waste generation is less. That might be the one possibility. And another one is they use more effectively the third bin, just go to the separate as the garden waste, not end up in the landfill. Or it might be both of the reason. But this is that how the regional thing, waste management system can be vary the composition of the waste. So what we practice is that we try to understand how we can apply our previous method in here. So the first column presents the Brisbane City Council. The second one is the Sydney, using the Sydney waste physical composition we calculate there. And the third one is the hypothetical case. What if we remove 50% of the food waste and garden waste, which are not the very low chlorophyll value component? And then now we got the net energy content there. So Brisbane is the lowest, and followed by the Sydney municipal solid waste, and then the sorted one. So this is how we can analyze it. So And then after that, we try to understand with some SSI, seeing that, okay, if those are going to the modern waste to energy plants, what should be the emission? So we need the very sophisticated model to do that, and that's we don't have. To do this, we need the very high complex process that involves fuel is the high, because fuel is a very non-homogeneous fuel. And because of that nature, we have to include a lot of the realistic value there. So what we try to do is that we try to do the simple mass balance approach, but doing a lot of assumptions that represent the real waste to energy plant operating condition. So from there, what we do is we do the, try to estimate the emission. So the first one represents the Brisbane, the second one is the Sydney, the third one is the Sydney sorted one. The last one is the typical range from the literature. But bear in mind that this is not going to the stack. This is from the, after the waste is combust in the boiler, it's just an exit from the boiler that's going to the series of the gas cleaning system. So which means if it is more polluted, you have to put more cleaning process is required. So as we can see, the higher the energy content, the better the fuel, the emission limit is lower. So this is how we can, this highlight two things. One is how important the understanding of the feedstock and how they are changing, especially the moisture content, because it significantly affects the value. And then that also can apply, we can estimate how much cleaning process is required at the end. So now let me briefly introduce about our other involvement in the waste to energy and waste and biomass area. And this is from the Biosolids. So as you can see that in wastewater treatment, after the water is treating, final product is coming out, is we call a slag of the biosolids, depends on how you call it. And those are very high moisture content and high ash. Currently, they are end up in the, according to their grade, they are end up in the different type of the farming landfill. But for example, in Brisbane, they have to go to very far, about 150 kilometers from the Brisbane to dump them. So because of the high moisture content, it's contained a lot of very heavy, and it's cost significantly for the transporting. So for example, it's cost about, I think, $10 million for the transporting only. So what we do is we try to understand what should be the alternative using those biosolids, because they have the energy content is there. So what we do is we do the analysis on the gasification, pyrolysis behavior. And this is the one whole project that we present in the 2 years ago bioenergy conference, but here is only the one slide. Oh, sorry, I'm just talking to this is for the biosolid. Previous slides is the gasification reactivity of the different samples. So we have the 9 combustible sample. That 9 combustible sample have the different reactivity. So this is quite a very significant reactivity science fundamental. Try to understand about how the food waste is gasification rate. What is the best gasification rate of the garden waste, plastic, etc. So we see that they are in varying about 2 to 3 order of magnitude. So what happens in the real gasification system, because of the non-homogeneous behavior, if you put the waste to energy plant, the consumption of each category is different on their reactivity. So it can be, at the end of the operation condition, what going in and what remaining may be significantly different. So this is one of the findings. So we have to care about that. If that less reactivity value is a very high proportion in the original mixture. And we have the really fundamental study, try to understand the characterization of the waste, reactivity of the waste, etc., pyrolysis of the waste. And this is one of our facility. What we have, it is a fixed bed gasifier. That's the facility we use to gasify the wood waste, mostly the wood chip, wood pellet, and the high density wood waste, bark or those things. It can go there, we can produce a syngas that can go to the turbine or engine after we do the gas cleaning process properly, and we can produce the electricity. So those are the showing the temperature profile and the tar content, effect of the air, and the quality of the syngas. This is just a brief introduction again. So this is the analysis of the mineral matter. One thing is, in waste to energy, not completely remove the requirement of the landfill. It's because of the mineral matter. And it depends on how you deal with them. Maybe you can separate them with the separator. You can manually separate all the glass and all those mineral matter. But still, there will be the mineral matter from the wood waste, all the combustible waste, wood waste, plastic waste, garden waste, textile, etc. So that mineral matter may or may not contain the handful amount of the heavy metal. So in our next project, this is what we are currently doing now. Using all those samples, we have it, and we are processing to produce replicating the real combustion condition and the gasification condition in the real world practice, and we try to produce the mineral matter. And we analyze there for the trace elements and leaching tests. And we can find out, are they harmful, and what should be their level, are they limited beyond or lower than the standard allowable limit. And it will be interesting to see what is the difference between mineral matter produced from the combustion process and gasification process as well. And we have quite a lot of biomass database as well as the other ways because throughout the CSIRO research activity. So we are now developing a database for the about 100 Australian waste and biomass. And after it's finished, it will be available for the public domain. All right, this is a summary. So as you can see that what we do here is quite fundamental because this is our role. We try to understand the researcher point of view. So we try to understand the waste characterization, waste chemical properties, and what is their reactivity, what is their mineral matter chemistry, so that if someone asks or we can get this basic information that can apply in real world operation condition and see that, especially try to match the feedstock and the suitable technology. And this morning, Mike tried to emphasize that we need data, very reliable data. It can be the statistic for the overall, or it's also include this kind of the fundamental technical data that can be contribute for the deployment of the waste to energy in Australia. And this is the application and waste team photograph. And I will conclude my presentation here, and then I will hand back to the Ted.
Don't run away yet. We've